Hey everyone, happy holidays! So this is the part of the year when everyone posts those LED lighting related videos. And yeah, to be honest, this one will be also about LED lighting. But instead of something that is related to Christmas, I will show you a way to create decorative lighting that can be controlled by your smartphone, via your home automation, from your network, or from remotely. And yeah, what else? It's cheap, it's easy, and doesn't require knowledge on electronics engineering or programming or stuff like that. So everyone can do it. If you're interested, keep watching. So let's start with the end product. This is how it looks like. Or actually, this is how the version I made for this demonstration looks like. Because remember, this is not a step-by-step tutorial, and I want to show you the basics instead. So you can use your imagination and create the light you want. Want to see something that is even more cool? Here we go. So this is my smartphone, and I can control the light here. I can change the brightness, and I can actually do a lot of stuff with this. And I don't really need a smartphone to control this, so this is a web interface I can access from anywhere in my network. So let's get started. Let's see the parts. First of all, the whole thing will be controlled by this little guy. This is a Wemos D1 Mini. It's a microcontroller, and this is pretty much most of the electronics you will see here, except the LEDs, of course. So you will need one of these. Then you will need a bunch of those RGB LEDs. So I will put a link in the description for the exact LEDs I'm using here. These are individually programmable RGB LEDs, and we will use them connected to the D1 Mini to achieve what we want. This is pretty much all the electronics. What else you will need? You will need a soldering iron, a clean soldering iron, and yeah, pretty much that's it. A little bit of soldering, and then we will get to installing the needed software. That will be also easy, trust me. So the super cool thing about these LEDs is that they are extremely well documented and widely available. So yeah, you won't need this information, but we need the wiring. This is pretty much we will accomplish. So as you can see, each of them has 4 pins. One is called data in, one is called data out, and you will need to provide some juice for it to work. So obviously that means 5 volts and ground, and this is why you need the D1 Mini, because this is one of the cheapest microcontrollers that can provide a 5 volt input for the LEDs and of course a 5 volt data signal. So this is the connection you will have to make. You will have to arrange your LEDs in whatever shape you want. I did this with a Christmas tree shape for this holiday, but you can do anything. And you don't even have to have a 3D shape. You can put them in a box or whatever. It's totally up to your imagination. Point is, you just need to keep them in line. So first, this is coming from the D1 Mini, data in. The second data out goes to the next LED, and so on and so on and so on. And of course, you have to solder a pair of VCC and ground wires for each of these 2 pins. This is pretty much all the soldering you will need. So just let me show what I did for this Christmas tree. Oh, it is ugly, right? Honestly, yeah, ugly. This is just a 5-minute project from me. I just made for my daughters, but honestly, when they saw it, they obviously did not care how it works in the inside, how it looks like in the inside. They were just amazed by the LED effects. And that is the point of this whole project, to create some decorative lighting. So obviously the wiring is hidden, and again, no one cares. Also notice that I did the safest and simplest route here. So I just placed the LEDs in a distance that I can directly solder together the data out and data in pins. And I use these brown wires for the ground and the green wires for the VCC. Obviously, if you want to go super crazy on this one, you can design a PCB or stuff like that, but again, this is not part of this video. Also, you have to know that these LEDs come in two sizes. One is 8mm and the second one, the smaller one, is 5mm. Apart from the size, they have pretty much the same characteristics or very similar, except the brightness. The brightness difference is really noticeable. So I use the 8mm ones on this Christmas tree, and on full brightness it pretty much lights up an average size room. I mean, not lights up because you won't be able to read or stuff like that at that light, but expect some crazy light effects on the wall. So it's pretty cool. And also a good thing that with the software running on the microcontroller, we will have a control for the brightness. So as I mentioned before, I don't want this project to involve any kind of programming, but for having stuff like this, you have to use a program. So we will use a ready-made firmware. This firmware is open source, it's called Tasmota, and you might heard about it before. It is used for those son-of devices. So actually you can upload this to any ESP8266 based device, which is the chip, the D1 Mini and the son-of, and some other controllers or smart switches are built around. To upload the firmware without too much hassle, we will use a tool called Tasmotizer, which is also open source and freely downloadable. Also, we will need some setup and we will be ready to use our LED-based project. So first you want to download Tasmotizer. You can grab it from GitHub, go to releases, and then you can download it here. So now that you have Tasmotizer downloaded, this is actually where you should start with your project. So no soldering up until this point, you just have the D1 Mini and you want to have a micro USB cable connected to your PC. So let's do that. First, you will need to know which port it is connected to, and because the operating system thinks about ports in a different way than you do, you have to be careful here. So by default, you can see I have these ports occupied in the system because of the devices I have connected to my PC. So it is 1, 4 and 3. Now I connect the D1 Mini. And then hit refresh. And now I have COM3. So this is the new device that I've attached, and I'm like 100% sure that this is the COM port I want. Okay, cool. Now you just select release. This will download and install the latest version of Tasmota on your device, on your D1 Mini. So you don't have to do downloading or compiling or whatever manually. So you just hit Tasmotize. Okay, cool. So this is completed, and now you have a D1 Mini running the Tasmota firmware. So power cycle means that you need to replug or unplug it from the PC and plug it to whatever USB power source you want to run it with. So the D1 Mini itself is a headless device, meaning that it has no keyboard or mouse or display or whatever, so we will use a web interface to configure it. And for that, obviously it will have to access the network, and since it is a wireless device, you need to somehow provide Wi-Fi credentials. So like with many other smart home devices, you will need to use your smartphone here. Okay, so the deal is the usual. Go to your Wi-Fi settings, then look for a new access point named tasmota_ something. If you can see it, move your phone closer to the D1 Mini. So you connect to it, then scan for Wi-Fi networks, then select your Wi-Fi network, provide your password here, and then scroll down and click Save. Tap Save. After that, your phone will be disconnected from the D1 Mini, and you can continue setting up the thing on your PC or on your phone. For me, a PC is more convenient. Now, before actually you can continue with configuring Tasmota, you have to do one thing. So you go to your router's web interface where you can see all the devices and look for the same name that was the name of the wireless access point created by Tasmota. So for me it is this one, and you will just have to copy this IP address into your browser. This takes you to Tasmota's web interface where you can do the actual configuration. So as you can see, by default it's configured for a son of basic, which we don't have at the moment. I mean, it's not a son of device, right? So you go to configuration, then configure module, then select generic, which will expose pretty much all the functionality of the ESP8266. So you click save, and the device will restart on its own. Wait a few seconds, then go back to the main menu. Now it says generic module. So you can go to configuration, and you can configure a lot of things here. For us, the most important is to configure the LED. So you will have to select this one. This is the D2. This is the pin where you will solder the signal in connection of the first LED. I will show a connection diagram, just a reminder, in a few seconds. So you select WS2812. So this is the actual LED chip, which is part of those LEDs we are using. So select this, and once again click save. Once again the device will be rebooted, and when you go back to the main menu, now you can see we have different controls, and we have a toggle for turning the light on and off. This is the point where we are done with the software configuration, and we can start actually trying to use the LEDs. So disconnect D1 Mini from your PC, and let's do the soldering. If you're not really comfortable with soldering, or just want to test out things before actually start to solder more LEDs together, then you can do what I did here. I just solder the single LED to the D1 Mini directly. After that, apply some USB power, and then go to your control interface and turn the LED on. It should light up. Feel free to play around with the settings. After some time, you will probably notice when you change colors here, there will be a slight shift on the color of the LED compared to this one, and namely, most probably your red and green channels will be shifted or actually swapped. It means that whenever you select green here, the LED will light up as red, and vice versa. And for this, there's a solution. This is a non-issue, or actually not an issue, but more like incompatibility between different LED types. So to solve that, you go to console, and then we will have to adjust one-time command or setting here. So there's a page dedicated to this command actually. It's called set option 37. So I just copy that here, and then for the actual setting, there's a lot of different values here. You can experiment with the right one. For me, 24 was the right one that worked. This is basically the order of RGB components in the LED. This can be different from LED to LED. I mean, between different types. So let's try 24. So here we go. Okay, and now my LED is lit up as red. So I go back to main menu, then select a different color. Now it's green. Okay, so problem solved. So we're technically almost done with this tutorial, but there are two things left, and two easy ones. So first of all, effects. You have seen that nifty little effect on the Christmas tree I've shown at the start of the video. So effects can be configured via the console. Yeah, not really optimal, not really user-friendly, but unless you want to change effects regularly, it's not a problem. It's also a one-time command, so the light, or actually the microcontroller, will remember the setting between restarts. You can unplug it, you can replug it, and it will continue where it left off. So you go to console, and then there's a command called scheme. Actually, it's well documented again in the Taskmaster documentation. So scheme, and after that the single parameter is a number. This number tells you what built-in effect to use. So you can start experimenting with it. Actually, the one you have seen on the Christmas tree is, guess what, this number 8, the Christmas pattern. Okay, so this is about effects. Once again, you can just enter scheme 8, hit enter, and there you go. Obviously, with this single LED configuration, it makes no sense. Okay, the other thing I wanted to mention is how to integrate it, integrate the device with your Amazon Echo, for example. So you go to configuration, then you go to configure other, and here you can see this emulation part. So if you change it to this one, click save, and guess what, once again restart the device. I mean, the device reboots itself. Now it's actually discoverable, so you can tell Alexa to discover device. So Alexa, discover my devices, and at this point Alexa will pick up your device, and it will show it as a device you can turn on and off. Unfortunately, you cannot configure the effect nor the color through the Amazon Echo, but you can use it to turn it on and off, and also you can make it part of your routines. Okay, so time to conclude the video. I've already shared a lot of information, but if you missed something or have questions, then use the comments below. And yeah, that's it for today. I hope you liked the video, and hope to see you next time, next week, and next year with a new video. Until then, happy holidays, guys. You're still here. That's good, because that means you kinda liked my video. If so, feel free to check out these other videos too. And if you're new to the channel, please consider subscribing. That helps me a lot. And yeah, if you click the bell button, you will get also notified about new videos.